Good day everyone, my name is Peter Carl Tiaganas. Buckle up with the new discussion, which is the laboratory experiment, qualitative and quantitative test for lipids. And these are the following materials. So firstly, we're going to elaborate the qualitative analysis of lipids help us determine the presence or absence of lipid depending upon the color change. Lipids are the organic biomolecule soluble in nonpolar are organic solvents like chloroform, acetone, and ether, and insoluble in water. Lipids are simple, complex, or derived. Simple lipids are ester of fatty acids with various alcohols, fats, ester of fatty acids with higher molecular weight of monohydric alcohols. Complex lipids are ester of fatty acids containing group in addition to an alcohol and fatty acids. Phospholipids or glycolipids. Derived lipids include the fatty acids, glycerol, steroids, other alcohols, fatty aldehydes, and ketone bodies, lipid-soluble vitamins, and hormones. To study some of simple tests and to identify the presence, the oil, and the fats in the given examples or given samples, this is the theory of the fats and oil are greasy in nature and on hydrolysis with aqueous of alcoholic sodium or potassium hydroxide liberate glycerol. Fats and oils are of vitamins of animals' origin and the vegetable. The following tests to identify the presence of fats and oils. The first qualitative test is the first formula is the solubility test. Second is the translucent spot test. Third is the acrolein test. Fourth is the Baudian test. Last is the Hubel's test. So the first step that we're going to determine is the solubility test. Fats are soluble in organic solvents like chloroform. Alcohol, it is the insoluble in water. So if the given sample forms an oily layer above the surface of the water, then fat is present. Partially soluble in alcohol and fully soluble in chloroform, then the presence of fats is confirmed. Note, if the sample is miscible with chloroform and immiscible with water, then the fat present is confirmed. The second step to determine is the translucent spot test. In this test, the given sample to be tested is rubbed between the fold of filter paper. The appearance of translucent spot confirms the presence of fats in the given sample. Note, if there is a presence of translucent spot, then the presence is fats is confirmed. Next step is the acrolein test. Fats and oil when heated with some crystals of potassium bisulfate KHSO4 in a test tube. A pungent, irritating odor or smell of acrolein confirms the presence of fat and oil. Note, if there is a pungent, irritating odor, then the presence of fat or oil is confirmed. For the fourth test or step is the Baudian test. The Baudian test is applied to distinguish between the dense ghee and vanaspati ghee. Vanaspati ghee contain 5% sesame oil, pure ghee does not contain sesame oil. Fats and oil are treated with 5 ml of concentrated hydrochloric acid and 2% fulvilar solution in alcohol. After the 5 or 10 minutes, rose red color appearance shows the presence of sesame oil in the given sample. Note, this test is used to find out whether the given sample of this degree contains valence spatty or not. The last step we're going to determine is the Hubel's test. This test is used to know the degree of unsaturation in the given example. Oils on reaction with Hubel's reagents fuzz the violet color of iodine, then it is the unsaturated, and if the color persists, then the given fuzz of oil is saturated. Note, in this test, various oils can be improved or compared on the basis of unsaturation. And the preparation of reagent is the Hubel's reagent. Mix equal volume of 7% mercury chloride in alcohol with 5% solution of iodine in 96% of alcohol. So the given procedure of the solubility test is, first step is take 3 test tubes which contain 5 ml of given sample solution to be tested. Next is add 5 ml of water to the first test tube and observe the solution. The second step, to the second test tube, add 5 ml of alcohol. The third step is, in the test tube, add 5 ml of chloroform. The fourth step is observe the change in solubility of the given sample. If it is soluble in water, then fat is absent. If it is sparingly soluble in ethanol, then fat is present, and same for chloroform. The second procedure is the translucent spot test. Take the sample to be tested, press a little in the folds of the filter paper. Unfolding, if there is the appearance of greasy spot, indicates the presence of oils and fats. The spot grows larger on heating and drying the filter paper. The next procedure is the acrylamide test. Take the sample to be tested in a test tube. Add few crystals of potassium bisulfate to it. Heat the mixture and observe the change of odor. If there is pungent, irritating odor, then the presence of the fat or oil is confirmed. And for the next procedure is the Baugen test. Take 5 ml of melted ghee in a test tube. Add 5 ml of concentrated hydrochloric acid and 2 to 3% of follicular solution in alcohol to it. Keep it aside for 5 to 10 minutes. If there is the appearance of rose red color, then the given ghee contains valence spatty. For the last procedure is the Hubel's test. Take 2 test tubes and add 3 ml of chloroform in each. Add cottonseed oil in one and linseed oil in the second test tube. Shake the mixture well and add 3 drops of Hubel's reagent in each test tube. The violet color of iodine fades away in linseed oil test tube, while the color does not fade away in cottonseed oil. This shows that linseed oil is more unsaturated than cottonseed oil. Next, the quantitative test. There are 2 types of quantitative tests. These are the saponification test. Ester can be hydrolyzed by alkali to yield the parent alcohol and salt. When the fatty acid processes a long chain, the salt form is a soap, which is the commonly used. This process called saponification. Oils and fats usually contain long chain in fatty acids and are therefore the starting materials for the preparation of soap is, first take 1 ml of the oil in the test tube and add an equal amount of alcoholic KOH solution. Mix them thoroughly and keep the mixture during the course of warming and shake up gently with as little distilled water. Appearance of soil is the drop will indicate the incomplete saponification. After complete saponification, no oil drops will appear. The next type of quantitative test is the rancidity. It's a very general term. It is the most general meaning. It refers to the spoilage of a food in such a way that it became undesirable and usually unsafe for consumption. When people say that a food has gone bad, what they are usually thinking about is rancidity. Most of the time, but not always, rancidity can change the odor or flavor of the food in such a way that it became very unpleasant to smell or taste. Oxidative rancidity causes oxygen damage to a food substance. It occurs with unsaturated fats. Therefore, the natural oil structure is damaged and interrupted by oxygen molecules in such a way that it changes its color, taste, and smell. It leads to the formation of toxic compounds like peroxides that damage vitamin A and E in foods. In oxidative rancidity, unsaturated fatty acids of glycerides are oxidized at their double bond. Thus, this reaction causes the release of ketones, volatiles, aldehydes, and acids. It can be prevented by an oxygen-free atmosphere, light-proof packaging, and the addition of antioxidants.